Good Wednesday to you, everybody in Gov 603. Welcome again to week 13 and our review of week 12, what you did last week. All right, let's make sure that we get things started up correctly. Last of the coffee. All right, now I'm sufficiently caffeinated and ready to start your review. We have been looking at some more terminology, things that you might come across when you read or when you research. And so it's these sorts of things in particular you want to pay attention to. I don't like jargon, but it's in any industry, any endeavor, any group creates its own jargon. So if you're going to be functional, even as an investigator, evaluator, you may not be conducting the empirical research, but if you're going to be functional, you got to know the vocabulary. You got to know the language. Okay. All right. Let's take a look at question number 1 from last week. We're dealing again with variables. What are they? And remember, before we get to question number 1, remember that when we say variable, we're talking about any instant. It can be something that actually happened, or it can be something that somebody felt, or it can be an opinion that they had, something that has an interaction with something else. That's a variable. Okay, question number 1. What is a dummy variable? Ho, ho, ho. Okay. How is it created? Why would a researcher use it? Either post an example in your response or link to an example online. Okay, now I gave you a little video to explain this to you, but Cynthia, let's go to you. A dummy variable is also known as an indicator variable. This type of variable is used to represent categorical data numerically. To make this adaptation, the researcher must first decide which categorical variables to represent using the dummy variable. Okay, that's an excellent answer, Cynthia. It is a correct one, but let's translate that to English. So let's say you're doing research that requires categorical variables. Okay. If you remember way back, okay, we talked about t-tests. You can use a t-test. You can use categorical variables to use a t-test. And in the example that you give here, Cynthia, you've got a bunch of people taking a survey. And let's say you're working for a sunglasses company. I know that's got nothing to do with political science, but just humor me. And you've got a bunch of different eye colors. And this is back to your example, Cynthia. So brown, blue, hazel green, more brown, let's say green brown or something, or black brown. Okay. But that people that have blue eyes, that their retina tends to be more light sensitive than people that have darker irises. Mine are sort of blackish, brownish black. The darker here, the less light that gets through the eyeball and the less light that hits the retina. All right. So let's say someone has a very light blue iris. Okay. What you want to do is you want to construct research. You want to construct a t-test that looks at how much squinting people with blue eyes and non-blue eyes do. Eyes that are blue and eyes that are not blue. But you've got all these people in the survey with these different colored eyes: brown, blue, hazel green, black. Okay. So what do? Well, you take those categories from the original data and you put them into categories that you create. And in this case, you would create 2: blue eyes, no blue eyes. And so in the example that Cynthia gives, she uses 0 and 1 to represent if someone does not have blue eyes, then that's a 0. If someone has blue eyes, that's a 1. Because remember, in this experiment, this t-test that you're setting up, you're looking specifically at just the blue-eyed people, and if there's any difference in, let's say, how often they squint as opposed to the non-blue-eyed people, whatever that non-blue-eyed is. So you create 2 categories. and then you group all of the data into one of those two. Those two categories, that's a dummy variable. So what it does, it allows you to take a whole bunch of variables and reduce it to a binary choice, this one or that one, by meaning, you know, this one or that one, and then represent them numerically. Now, it doesn't have to be 0 and 1. It can be 1 and 2, or, you know, 7 and 8, whatever two numbers you like to pick. Okay, so let me go through another person and make sure that everybody understands this. Nicole, a dummy variable, otherwise known as the indicator variable, is a variable that correctly incorporates categorical variables by predicting a dichotomous quantitative relationship between the variables that can now be tested. Okay, so here we go. So per the example of how to use dummy variables in regression analysis, a researcher wants to use marital status and age to predict income. The researcher would need to convert marital status into dummy variables. Okay, so there could be single, married, divorced, widowed. So all you want to know is married, not married. That's it. Right, and on your table you have divorced here, but let's just say it's married, not married. So you might have changed that table just a little bit, Nicole. Okay, so you're either married or you're not. And in that not category is you're single, you're divorced, you're widowed, but you're not married. There's a dummy variable. Okay, and you can represent married as 0, or you can represent married as 1, and not married as whichever. Okay, does everybody understand that? If you do not understand that, please reach out to me. Okay. All right, question number 2. What is a categorical variable? Either post an example or link. Natalie, categorical variables separate observations into different categories, but relationships are not mathematical. That is, this is used in statistical research that involves qualitative data. Okay, let me tweak that just a little bit. That it's not that it involves qualitative data. It is, in effect, qualitative data. Now, remember what I have said in the past, that a variable is not a thing like, let me finish my coffee. Okay, a variable is not a set thing like this cup and this pencil are set things. This cup is not this pencil. Now, they're both made out of material. You could make an argument that they're made out of the same, you know, atomic particles. Okay, but they in no way serve in the same function. I can't drink any coffee out of this, and I certainly can't write a note with this. All right, so these are actual separate things, distinct things because of their nature. Variables, whether they're categorical or continuous, are categorical continuous because you, the researcher, describe them in that way. You decide to describe the data, whatever you're observing, either categorically or continuously. All right, so don't be fooled. Don't be, kind of psyched out like, oh, what's categorical? It's how you describe the thing. All right, so let's go back to question number 2 and the question of, well, what do we mean? We say categorical variables separate observations in different categories, but relationships are not mathematical. Okay, so what that means is, so for instance, categorical variable. Age is a categorical variable. Gender is, which there are only 2, is a categorical variable. But you could describe both of those. You could gather data in a way and describe them as continuous. So let's say, you said to someone, as often as we often hear, how do you identify by way of your gender? Now, this is separate from political science, but I'm gonna tell you, as a researcher and someone with a background in biology, there is no science behind gender spectrum theory. It is theoretical only, and it is largely psychological, not biological. And that's just the facts. I'm not wading into the politics. I'm giving you the facts before we proceed. But let's say you were, what you're measuring, and this is often an interesting distinction when you make a measurement, is distinguishing between what something actually is or how something is actually done and what someone believes something is, or they believe how something actually done. Weight loss is one of these areas where that crops up a lot. Let me give you an example. You could measure how many calories someone takes in a week. All right, that's important. Let's say if you're trying to figure out strategies for weight loss over a broad population, you can measure how many calories they take in a week. That's important. But just as important, but different, is how many calories someone believes they take in during a week, which is different, but also very important to you making a measurement, a determination for a weight loss strategy across a broad population. So let's say that you put together, you want to measure perception of gender. You could set it up, say, well, what, on a gender spectrum, where do you identify? That would be capturing the question of gender as a continuous variable, not a categorical variable. Okay, so categorical variables. Sean, let's look at you. Categorical variables places observations into distinct categories, such as these variables are either of the nominal or ordinal type, meaning you count them up. With categorical variables, there's not a spectrum upon which observation could populate anywhere, but observations are grouped into one category or another. Remember, you as a researcher are doing this. Okay, question number 3. What is a continuous variable? Provide an example, link, etc. Jared, continuous or discrete variable. And by the way, on the American side for statistics, we don't use terms like discrete very much. It's British. So you'll see continuous variable. Okay. Is a quantitative variable that can take on any value within a certain range or interval measured on a continuous scale, meaning there are an infinite, hypothetically, number of possibilities. Okay, so you could say to somebody, how much money did you make this year? That you could describe as a continuous variable by just letting them fill it in, or having a whole set of ranges, between this much and this much, between this much and this much, between this much and this much. All right. There's a type of question called a Likert scale question, Likert, Likert, named after the researcher Likert, that uses, it's always an odd number and it's frequently 1 through 5, and it uses the distinction to try to measure emotional reaction to something. And so it usually starts by, it gives a statement to the survey taker saying, politicians are dishonest. I'm just throwing that out there. Okay, making that up. Then on the Likert scale, number 1 usually starts with a negative and moves towards a positive. Strongly disagree, no opinion, agree, strongly agree. So you're measuring someone's emotional response or their opinion to something. That's considered a continuous variable, although there are 5 distinct categories that you're forcing someone to choose from. So it's a little, there's a little, there are a few exceptions within the research world to categorical or continuous variable. But if you see a Likert scale with Likert scale questions, that's a continuous variable. Okay, everybody understand the difference between categorical and continuous? If you don't, email me. Okay. Question number 4. Look online and find an example of regression analysis with a categorical variable, with categorical variables, post or link to it. Okay, so normally regression analyses are done only with continuous variables, but there is a way to do it. Nicole, an example of regression analysis with categorical variables can be found in How to Use Dummy Variables in Regression Analysis. Very good. Using the previous example of marital status and age to predict income, the regression output of the variables as follows. Okay, here we go. Here's the p-value. Okay, to find the estimated income individuals based on their age and status, researcher can use the fitted regression line. And here we have the equation: income equals whatever the income is, then plus age, plus marital status, et cetera, et cetera. For example, if an individual is 23 and married, their estimated income would be $42,000, et cetera, et cetera. Okay. This is one where I wanted you to be able to go out and find the thing and then bring it back so I could check to see whether you understand the thing And in this case, regression analysis using categorical variables. So there's not necessarily a right or wrong answer, except perhaps the example that you go and get. Right? And I'll look at that when I grade this discussion forum. Okay, everybody. That is it for your stuff last week. Keep working on those papers. Keep studying for that exam. It's going to be cumulative, just to review, cumulative. No, there will not be a review sheet. The way you review is go back and review the discussion questions, all of them. If you took the midterm, now you get a sort of a sense of where we're going. So terms to be defined, concepts to be articulated and commented on, blanks to be filled, and short answers to be answered. And that's going to be the test by way of format, just like the midterm. Okay. All right, everybody. I hope you have a tremendous rest of the week. Remember, if you've got any questions, to reach out to me. I'm here to help you. All right. I'm thinking about you. I pray about you. Have a wonderful, wonderful rest of the week. And as always, I'll see you on Canvas. Bye-bye.